Hi, this is Raphael Joseph. My T1 is the X-bar, risk-adjusted X-bar control chart for HAP 725, taught by Dr. Farrokh Alemi and Dr. Uriyo. Question 1 states, in health administration programs, conducting satisfaction surveys are usually covered in courses on quality improvement. This exercise shows how data from satisfaction surveys can be analyzed over time. Assume that in different time periods, 4 randomly selected patients rated their satisfaction with our services. Are we improving? To answer this question, we need to calculate the control limits for each time period. First, we calculate the average for each time period. Second, the average of all observations. Third, the standard deviation of all observations. Finally, fourth, calculate the standard deviation for each time period. And now you are ready to calculate the upper and lower control limits. The formula for these calculations and the resulting findings are given by the next slides. To answer this question, I'll be using Python. Step 1, Python install. First, I imported NUMPY as NP, pandas as PD, matplotlib as PLT, and statistics. Data was read using the pd.read_xl, and I printed the head of the data to make sure that the data was retrieved. Step 2, NumPy array. The data was listed so that necessary calculations can be performed, and it was labeled under X. Step 3, for loop. X bar was labeled as the mean, S was labeled as the standard deviation. A for loop was created for the X bar and S so that the mean and standard deviation would be calculated. Step 4.1, X bar. The various markings were created, such as blue for the average reading, red dashed for the upper and lower control limits. These were given for the plot. The mean was given a black color. The formula for creating the upper and lower limits included using the mean plus 1.96 times the mean of the standard deviation. The X and Y label was given time period and satisfaction rating. The legend was created at the upper left corner, and the plot was exhibited by using plt.show. Step 4.2, X bar. As you can see, the plot was given the control limits and the observations. Note that the upper control limit and the lower control limit are drawn with dashed lines and in red. There are only 3 observations in this time period. Also note that the second time period falls below the control limits, showing that in this time period we did worse than usual. Step 5, validate points out of control limits. This code signifies that if the group is greater than the upper control limit or the group is less than the lower control limit, it will print out the group number out of mean control limits. If true, then it would print all points within control limits. The output shows that group 0, 1, and 3 are out of control limits. In conclusion, the control limits are plotted on lines above and below the center line, i.e. mean, in the quality control charts that function as thresholds to identify signals, i.e. points beyond control limits, and help determining if the process is under statistical control. Potential errors and fixes. After further review, the control limits were not accurate, since group 3 should not be out of the control limits. The potential source of the error was including the empty columns for the ratings of the second and third patient, since their rating was not surveyed, thus changing the mean. In my opinion, a more accurate way of creating an X-bar chart is using Microsoft Excel, since the data was easily visualized. Thank you.